Again, notice the time, on 9:28 at 12:54. This is when the call started. It ended at 1:47. And what I really like about EdgeDX and the rest of the ControlUp product family is that it takes a holistic view of the environment. So knowing you have a Teams issue is great, but actually taking that data and being able to relate it back to the device at that time and figure out why it was having issues is really what we want to get to. That lets us do root cause analysis, failure analysis, things like that. Let's go ahead and click on this, and this is a hot link. It brings us back to that device at the time that the failure happened. We can see this is a Windows device, Windows 10 device. We can see that, it's actually a Surface 3 device, interesting. And then where we see a lot of issues is with networking, and has a couple different networking devices associated with it. And it looks like it has some Ethernet there that maybe, and some a Bluetooth device on it as well. So all these widgets are set to the time frame of when that team call happened. And one of the neat things we do is if you hover over one of these issues or one of these dots, it'll tell you what processes were running when you were having, for example, we're having a CPU of 100% or at 93%, and Teams was using 30% of the CPU cycles that time. We can also see that we had some CPU queue length latency or queue length issues at the same time. Queue length of 27. That's why the CPU was being 100% utilization. And CPU queue length really is what you want to look at and what you want to investigate when it gets up there. And kind of the rule of thumb is you don't want a CPU queue length of more than 10 per core in the processor. This has 4 logical processors. Right there, we can see that. And so 30 is getting a little bit high. And basically, CPU queue length means you have a request into the CPU that has to wait in line to be serviced. But again, towards the end of the call, we have a few highlights, but nothing really horrible there. Network usage isn't very bad. The latency getting up there a couple places. Towards the end of the call, we don't see it. But again, one of the neat things we do is we can go ahead and click this, and what we can get is a trace route. And when they were having the high latency from the device itself to, it looks like its router, that first hop was 111 milliseconds. So inside the user's environment, it looks like that's where we're seeing a lot of latency. The rest of the line is pretty clear. And you'll see some of the graph has these hash lines on it, and that just means that the node itself wasn't reporting back data, so we didn't have anything to report there. So that's interesting that we did see 111 milliseconds there, and towards the end of the call, we can see that it was 22 milliseconds. So something changed, and like I said, it's probably in the user's environment itself. The other thing that we tend to look at is the Wi-Fi signal. It's at 100% most of the time. It does drop down some of the time to 60%. But overall, this device looks pretty good. Let's go back and take a look at the other device, Jason's device. And CPU usage looks good. And right there at the end, CPU queue length kind of got a little bit higher, but not seeing anything that's popping out at me until the very end. When we look at the Wi-Fi signal, it's 100% most of the time. And then right before the call ends, it drops down to 40%. So it looks like Jason's device, at the time of the call, his Wi-Fi signal just degraded to 40%. Another neat thing you can do here is if you want to get a little bit more in-depth look at it, you can certainly click on these dots and it'll zoom in to that specific time. So it gives you a little bit more granular look at things.